Okay, so let's take a look at how we can add tests to our Swift package, libraries and executables, and then we'll take a look at how to add tests to Xcode. All right, so to start with, we're going to look at packages and executables, primarily because a lot of unit tests specifically, if you are setting up your projects in such a way that all of your kind of logic and data transformation and networking and all that stuff is sort of happening within a package. And then all of the UI stuff is happening in the app that uses that package. You will be writing most of your unit tests in the packages, not within the larger app, right? But, neither here nor there. So, to start with, let's take a look at how we do that. So first, we have here our class 2 assignment implementation that I shared with you all that did all sorts of stuff that you hadn't learned yet. So it was probably not very helpful for you. Apologies. But within it, there is essentially, this is kind of the meat of it, which is there is a function that takes in a regular expression, which is defined up here. And that regular expression basically picks out plus, minus, divide by, or multiply when it's in between two numbers. And then you also put in, actual text from what the user uses in the command line, right? So, as we've done before, right, we can always test this by, hitting play, right, and entering passwords for some reason. Why do I have to do this now? Okay, whatever. It's just so weird when these things pop up and it's like, why now? What about all the other times? Right? Okay, so here, my thing, you just get to pick which string you use, right? We'll just use the regex builder, right? So then we're told to enter a number, an operator, and then a number to perform arithmetic. So we can say, oh, okay, cool. So we've got 2 plus 3, right? And it gives us 5, right? We can do 8 divided by 3, right? And do 2.66 repeating, right? And, this works fine, right? It suffices. For terms of testing, right? But it would be much nicer if we could just kind of test this sort of in a regular fashion, right? Now, one thing that's really interesting about this particular implementation of the project is that it's not very, very testable, okay? The way it's written isn't written to be tested terribly well, okay? And that's, just a reality of the situation that we find ourselves within. So, which means it's a great example for how to change something and make it testable. Of course, I'm doing it live. I haven't practiced this one particular. I just felt the whim to pull up this old code. So bear with me as I muddle through. Right. So first thing you need to do in order to start using tests, kill the process, is you need to create a test target. Okay. So first thing we're going to do, we're going to create a test target. So luckily, they have one all ready to go for us. Test target, name, dependencies, path, blah, 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 blah. Right? Perfect. So we're going to call this class 2 tests. That is typically the convention when you are making a new test target. Whatever target it is testing, you name it that, and then you add tests to the end. It's a convention. You don't have to do it. It's just, it's what everyone expects. Then the other thing to note is that when you are writing tests, you are using the functions defined in the target that you're testing, which means your test target needs to have a dependency on the target that you are testing. So you need to depend upon it and then import that target. So we're going to do that here. We need to set a dependency. Array, a list of dependencies. And then here we can do dot. And then luckily for us, there are some really nice, easy ones like by name. So we can just do it by the target's name, right? Because we know the target's name, it's right here, right? So, cool, that's all good. But we have an error showing up now, right? And it says resolving package graph failed. I'm reading this out loud because it is very tiny, tiny text. Let me see if I can get it bigger. Yeah. So basically it says target class 2 tests has overlapping sources. And then it has like the whole, the whole file path of class 2 sources / short regex.swift, right? Basically every single file, every single Swift file that's within there, right? It's complaining because right now there's only one sources folder. And so both of the targets in our package are trying to pull, they assume that that folder is for them and they're fighting over it, right? Like children, okay? And you need to separate those children and tell them to go sit in alone zones in the corner, okay? Because they've been fighting over code and they shouldn't do that, right? So in order to do that, it's very simple. You create a new folder, you call this tests, the error goes away pretty much instantly. Now you can create a new empty file. We can call this, I don't know, we'll call it arithmetic tests just because. All right, we have our test file here. Cool, I'm gonna get rid of all this because we don't need it. So first thing you need to import in order to test with Swift testing, the framework that we're currently using, rather than XCTest, which was the old framework, it works great. It's very stable. It's very nice. And it's also very old. It's basically, it worked on Objective-C like 20 years ago. So, just, this is the new hotness. This framework that you import testing, the Swift testing framework was first introduced in WWDC 2024. So less than a year ago. So this is a very, very new testing framework. That means that it's got a lot of the newest conventions, the coolest toys, and it also breaks more so than XCTest does, right? So it's not as reliable because it's kind of new. So just keep that in mind as you're using it, that it's, you are an early adopter along with everything that comes with that, right? Okay. So, oh shoot, I'm realizing now that I don't know if we're going to be able to run tests. I don't know if we're going to be able to import an executable because there is no library formed by it, but let's go ahead and try. So first thing you want to do is you want to import, and then let's see, what did we call our target here? Class 2, right? So class 2, oh, there it is, cool. Yeah, we can, awesome, right? Now, something that's very important, our test module, our test target is different from the target that we're testing. That means that access control comes into play. So right now, if we create a function, right, test example, right, and we try to create, let's say we try to call this regex builder function, right? Cool, right? Great. All right. So it'll be like regex builder. Well, where's our function, right? Why isn't it there, right? And the answer is it's not there because it's not public. By default, if you do not set access control, all functions and types are internal, which means they cannot be seen by other targets, right? So if we want to fix this, we could make this public, right? And then over here in arithmetic tests, we should be able to see it like this, right? And there's our function. However, sometimes when you have, for example, an exe, or you'll see this too when we start to look at doing this for apps instead of just libraries, which we'll do next. You really don't want to change your API just so that you can test it. There are sometimes functions that need to remain internal, things that should not be exposed to users of your library, but you still want to test them. Now, there is a bit of a holy war going on and has been for like decades between people who say, well, if you don't have that interface as public, right, then you should test all of your non-public code by exercising it through only your public API. So if you have some piece of code all the way down here that's reachable by calling this function and then this function and then this function in this order and passing the results to each other and doing all this stuff in your API, and the only way to get to that function is by doing that, they say do that. Just use the public API. The flip side of that argument is a lot of people really just want to be able to write really simple unit tests, and writing all of that boilerplate and cruft and stuff just to get to a single deep nested internal function in your module goes against the idea of unit tests, which is they are supposed to test a single unit of code, just one function, right? These folks, who I believe to be eminently more reasonable than those who say, please exercise everything through public APIs only, they, along with most language designers, agree on the idea of being able to import libraries using a marker that says, hey, we're going to be testing this library. Please give me its internal types, okay? So you can use the @testable macro when you import a library, if that library, I think, like, it has to be local. It can't be like a library you get from online or something like that, in order to get access to its internal types and functions. So now, when we do regex builder, we need to compile first. Sorry. Command build. Make sure it's all good. Cool. So now when we do regex builder of blah, 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 using, okay, wait, is this a situation where, oh, it's different. Each one's named something else, of course, right? Okay, so we've got basic regex and substrings and all that stuff. So we've got regex builder here, but note it's no longer public, right? We've got substrings of, right? We have basic regex, right? So on and so forth. They're all available to us now. We have access to internals, okay? So, cool, great, awesome. So now we can actually create our tests, okay? So, cool. So let's go ahead and take a look back at main. We have this regex here. It's kind of in here. It's not exactly visible anywhere, right? It's in this if available, but I guess it's technically global. So we should be able to access that out here. Let's take a look. So, we put this, then can we just say regex? And is it in here? Basic regex, short regex, strings, blah, 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 builder. Does not look like it. If we do class2.regex, no. Okay, so it's not global because it's inside of that this if block, which is fine. That's probably a good thing. It's an if block, of course. It is scoped to the if. It's not going to show up elsewhere. You could, if you wanted, put this out here, and then it would yell at you because regexes are only available, right? So yeah, that would be a pain to fix, right? So that's why it's in that if block. Basically, we have to kind of consider, okay, this example was written specifically not using structs or anything because we hadn't gone over those yet. So we could have something like, like a struct, right? That says, I don't know. Let's see. This is our just sort of arithmetic regex, right? And then we can put this, at available, right? Mac OS 13.0 star, right? This just kind of tells it, hey, this is only available if you're, using this level of Mac because, this library that we're using doesn't exist, right? Otherwise. So then we can create this, right? It's still complaining at us. I'm assuming we have to do this here as well. What's the problem this time? It's not concurrency safe, right? Right. Why is it not concurrency safe? Shared mutable state. How? It's non-sendable. I see. Could we just mark it sendable? Just say, hey, please be sendable? No. Okay, cool. All right. Well, we tried. So rather than take a while to untease how to do this correctly, we're just gonna hack it. We're just gonna do this. And then we're gonna wrap this whole thing in a similar if available, just so that we can actually start looking at the helpful testing stuff. Right, it's gonna be, so one thing you can do is you can also group tests together. So we talked about having multiple expectations within a single test. You can also group them together. Actually, before we do that, hold on, sorry. Let's just, we'll be even hackier, right? So we're just gonna put it here like this. And then we will have at available. Where's the syntax? Like this. There we go. All right, we put this here. Stops yelling. Cool. We're just gonna hack it for now. That's fine. All right, so now we have a bunch of them. So we've got basic regex of, right, using, etc. Right? So we can just do this. And actually, I think that with basic regex, let me double check it. It has a default. No, the default is nil. Okay, yeah, so we want to use that. All right, cool. So now we can put in something like 3 plus 5, right, using our test regex, okay? And, this is going to return us a value, okay? So we're going to say let result equals this. And now we know that result is of a type string because we're printing it out back to the console. So we would expect the result here to be the string value 8, right? So it's a string, but it has 8 as a character within it, okay? That's our expectation for this test, right? Okay, cool. So we've got our test here. How do we run it? Well, we forgot one thing. In order to run this test, we need to mark it as a test using @test, okay? You can kind of chain these together however you sort of want, it doesn't really matter. Swift doesn't care. I prefer something more like this, where they're kind of the wider one is on the bottom, but that's just me. And now you get this cool little button over here, okay? This button lets you run your test. You also, if you have done any exploring up here in these tiny little icons that are probably impossible for you to see, if you hover over them, you get a little description. One of them, and it looks like a diamond with a check mark inside of it, is Show the Test Navigator. If you go to Show the Test Navigator, you will also see your test there as well. And there's a little play button that you can use there to run it. So you can actually run tests when you're not even, individual tests, when you're not even looking at them in the code, okay? So here we've got our test, right? We want to run this, make sure that it works. Fingers crossed that this thing that I wrote months ago does what I thought it would. And it does not, because it returns 8.0, right? It returns a double. Right, okay. So we're gonna put 8.0. Kind of weird behavior, maybe I should go in and fix that, but that's a discussion for a different time. So we change this and we run it again and it succeeds. You get a cute, cool little green check mark that shows up here. It says succeeds. You get a green check mark here. You get green ones all the way up and down here. Testing, and it was fast. It was super fast. Testing feels really, really good in Xcode. It's intended and built to give you a little thrill, right? Just to make you excited. Almost like a video game, right? It's like, oh, cool, I got green check marks all the way. I did a good job, right? This is by design. This is intentional. People who first, were coming up with tests, they were programmers too. They know what programmers like. We like shiny things. We like things that tell us that we did a good job, and we like things that tell us that did a good job in a pretty, beautiful way. Test suites and things that exercise test suites almost always have some form of, here's a green shape or circle or something that appears when the test passes, and there's a red, bad, evil, no good one when the test fails. So, whether or not you agree with that color scheme or whatever, that it is what it is. So, cool. Okay. So this is your kind of basic test, right? Now, we could, presumably, right? What is it yelling at about? Oh, never mutated. Sure, of course. Yeah, we can be a let. That's fine. Now, you could continue to exercise all of the other different kinds of regexes in here. However, usually you will want to name your test kind of after what you're testing, right? You can name it test, whatever, right? However you want. And then rather than testing like all the different other kind of regex functions that I have in here, it makes a lot more sense to instead make result of R and test this function again using a different input. So here we can do 5 minus 2 using test regex, right? And then we can hashtag expect result equals, and this is going to be 3.0, right? So we can run it, and it passed. But, this expectation, I don't know. I'm not, my spidey senses are tingling, right? It didn't fail first. Can it even fail? If we tried to make it fail, would it? Right? So let's just verify that it can fail, right? Always a good thing to do whenever you're building a test, just to make sure, cool, okay, yes, it catches failures, great. Basically, you're testing your tests manually as you build them to make sure that they work, right? So that you can then rely on them later when you're coding at 2 a.m. trying to make changes and you're worried it's going to break something in a different part of your code. You can rely on tests that you made sure work correctly to help you make those changes in a safe manner. Also, go to sleep, drink more water, don't code at 2 a.m. Cool. So you can do that. Now, so we have these, but what if we wanted to do a test of, I don't know, the regex builder function, right? Where we build a regex in a different way, right? Well, we could do, regex builder of blah, blah, blah right here and so on and so forth. But, that's not considered best practice. Usually you can have multiple expectations within one test function, but the idea is that you are sort of testing the same function in different ways. And some people would even disagree with that. They would say break each of these out into its own function. That comes down to personal preference and taste. But when it comes to exercising a completely brand new piece of code, most people would agree that should be its own test. So let's go ahead and make a regex builder test. We'll do @test, and we'll do @available, macOS 13.0 star. Love these everywhere. And we're going to call this regex builder test, right? And we're going to bring in our little regex thing here. Kind of a pain. We're copy pasting it everywhere. Don't love that. Maybe I wonder if there's a way to fix that. Yes, there is, but we'll talk about that in a moment. All right. And then we're going to do all this. And, honestly, we're going to be bad here. Don't do what I'm doing. Okay. I'm just trying to save time because I'm teaching you. Don't perpetuate the violence of my mistakes. Okay. So here we're going to do regex builder like so, because they all have the same input types and result type. That's how we continue to reuse them outside, right? So we can just pass in the same information and expect to get the same result. So we can hit play here, and it passes. Great job. And now we can also play here because this is making us feel bad, right? Oh, look at that green up the board. So good. Okay, cool. Now, let's look at this. Okay, we have this thing, this piece of state that we are recreating in every single one of our test functions. That takes time, okay? First of all, if you ever want to change this regex, you now need to change it everywhere, okay? So in each of these functions, if we wrote a function for each, type of builder, you'd need to change it in each one. We need to pull it out, right? It was giving us errors and issues when we tried to do it globally, but that's fine because we are going to create what's called a test suite. So a test suite is basically a grouping of tests that are related to each other, tests that kind of belong together. For this very small project, it's okay to have one test suite, right? But if you wanted, you could have a test suite for the basic regex function, and then each test function would have a different single expectation. That's a valid way of doing it. Again, it's down to personal preference and how you prefer to break down your tests and organize them. Because at the end of the day, you answer to yourself. And to me, I guess, but like, I'm not grading you on tests. So that wasn't in the project requirements. You don't have to include them. They're just helpful for you. So, right. So let's say we have these tests. We want them to be in a suite together. How do we do that? The way we do that is by creating a struct. So we're going to call this regex tests, right? We're going to wrap our functions within that struct, okay? And so now this struct behaves in the exact same way as all the other structs, right? And by default, without any further annotation, right, this counts as a test suite just by being a struct. And you get a fun little play button right here on the struct. And when you click this, it runs all of the tests within the struct. Similarly, you have that over here. Now, of note, you do have, you know, this, oh gosh, not yet, we're not there yet, sorry. You do have these like higher level things where if you hit this, it will also run the tests, right? But those would run multiple suites if you had multiple suites. If you wanted to just run one suite, you'd click the play button for that suite. If you want to run one test, you click the play button for that test. You can do it in the navigator, you can do it on the line over here. Both of them did the same thing. Cool. There is also a suite attribute, right, that you can apply. This just moves the button a little bit, but it also gives you a few options that you can set. You can give it a name. So if we don't like the name regex tests, right, we could instead give this like kind of a human readable sort of English, you know, or whatever language name, where we could say something like, you know, regex input arithmetic tests, something like that, right? And over here in the test navigator and in any test reports that you get Xcode to generate, it will have that string. You can do this for tests too. So here we can call this basic regex, right? And now this one, instead of having the function name, we'll say basic regex, okay? Whether or not you do this, how you do it, what are your capitalizations, do you use spaces or underscores, right? All of those, once again, come back to personal preference. So, cool. Okay, great. So now we've got this great, awesome, wonderful, very cool set of tests, and they run and they exercise our functions and they do all that, and that's great. Awesome. But what if we wanted to test a whole bunch of cases? What if we want to test 5 minus 2 and 5 minus 1 and 6 times 12 and 100 divided by 3 and all that stuff? And we want to, let's say we have like 100 things that we want to test, and we want to do it the same for each one, right? Well, okay, so what you could do, right, is you could create a set of like an array of inputs, right, within here, like so. And then you could have this be like 100 divided by 3, right, and 50, minus 7, I don't know, 87, there we go. I fat fingered it, but it worked out. And 3 plus 5, right, and so on and so forth, right? Make sure negatives work, right, etc. This, and then from here, right, you could, in fact, if you really wanted, if you want to be fancy, right, you could make this a dictionary where each of these then matches with the answer, right? We're going to make this too, just so I don't have to like figure out the exact like where the repeating ends and starts to round, because that's going to be a pain. Actually, you know what? No, we're not going to do that. We're gonna do that because that's helpful. It's what we're here for, right? Something like there, maybe? We'll take a guess. We'll find out, right? And then here, 50 minus 87 is what? Negative 37? Like that. And then this is 8. And then this is negative 12, right? So these are the answers we would expect. Now, they should be doubles because we know that that's a thing that our stuff is doing. It's returning doubles, right? And this is kind of what we're expecting to see. Okay, so now that we have these, we can also, of course, because we're within a struct now, we can pull this out here and have it be a member value of the struct, and then we don't have to redefine it in each place. There you go, like so, right? So now we have these inputs, right? We can now go, oh, cool, okay, so now we create a for loop, right? And we say for input in inputs, okay? And then we're gonna do this inside, but instead of passing, hard set things, we're automating our automated tests, right? So that we can just set a bunch of values and then just kind of put it in. So here we've got input.key, right? Because that's the first one, and then the value, right? So here, the result will be the value. So we'll do input.value like this, right? Something like that. And then we can get rid of this, okay, right? And now then this is going to be, this next one down here is going to be exactly the same, except it's going to use regex builder instead of basic builder, or instead of basic regex. So we're going to, I'm struggling with the highlighting here. Okay. So we're going to do regex builder. No. If I do that, it will not accept what's already there. Okay, cool. So now we have this set up. So we've got these for loops. That's all good. Cool, great. Okay, so now we're going to go and we're going to hit play, right? And it failed, right? Well, okay, where did it fail, right? Okay, it failed here. But what about all of our other cases? Did they fail? Did they not? We don't know, right? Like the answers are up here in this text, sort of, right? But it's a huge pain, right, to find it. So there is a better way to do this, okay? There's a better way, and this should be a let so that we can get rid of that warning because warnings are ugly and we don't like them. You can do what's called a parameterized test. So with a parameterized test, if your test function takes in a parameter, like so, then it will give you this error. Attribute test must specify arguments when used with function basic regex inputs from macro test. Oh, okay, cool. Well, let's fix that. Click fix. Oh, arguments. Oh, look, it wants an array of these, right? And, we look at this and we're like, oh, okay, an array of these. Interesting. Well, this is just a dictionary, right? So, this is one of those things where you can instead make this like an array of, tuples, right? Like so, okay? And then make this instead a tuple, right? Like that, and like that, right? And this one here as well, right? And now, of course, the syntax for this needs to change. These need to be in parens. Changing everything. Okay, actually, hold on. It should be doable with the dictionary. I'm not going to mess with tuples, sorry. Okay, apologies. So it's saying it wants an array of dictionaries, right? We're like, oh, that's not exactly what we wanted, right? So for the inputs, what you can do is you can do like, I think it's like key value pairs, right? String, like this, right? And that's what a dictionary is. So we can now do this, we get this error, we can use fix, and it gives us an array of key value pairs, which is essentially what a dictionary is, right? It also added a ton of white space for some reason, no idea why. So cool, so now basically, this wants an array of these things, okay? So whatever you pass in to this is going to be, because it's an array, it's gonna run this test for each item in that array over and over and over again, right? So here, if we put inputs dot key value pairs, no. If we just put inputs, that's not quite right, because it is Yeah, okay. What do we do? Zip? No. Sorry, I'm just thinking about how we do this. We could do a map. It's annoying. I wanted a much simpler example for the first parameterized arguments, and I've ruined it. Key value pair. Dictionary literal, sure. And then we will have dot key value like that. I hate that. I hate everything about that. Can we not do that? What's the... Okay. All right. I guess we're looking at tuples again. Sorry. Apologies. This is what I get for trying to do it live. I think of ideas that are just ever so slightly too complicated to pull off. All right, so back to tuples. An array of tuples. So we just go in here and do like that. Control. Nope, that won't work. All right, we'll just put it at the end, I guess, like so, like so. Just fixing all of our wonderful dictionary syntax, right? Which it didn't need to be a dictionary anyway. So because we weren't using the key to access the value, we were just using it as an array of key value pairs. So that's on me. Okay, and now this is for our input. We have, and in fact, this is not just inputs. This is an input and a result. So let's call this just input and result. And it is a tuple with strings, right? And we could even name them, I think, if we wanted, like so, okay. And now we can do inputs like this. And is it not because I named them? It might be. I shouldn't have named them. I shouldn't try and be fancy, not in front of you guys. We're just doing the basics here. It's, what is your issue? Cannot be used on type regex tests. Oh, gosh. There we go. All right, so the way Apple has the arguments set up, they kind of expect you to do this right here, right? So they want you to do it like inline, right? But if you're going to reuse the same arguments in multiple tests, you'll want to have it be a property out here. In order to actually use them in the tests, though, you need to make it a static property so that it gets defined at the very beginning before any of the functions even get looked at, because it's a part of the function's definition. Cool. Okay, so now we have this, and we can go here, and rather than having this for loop, right, we just have this input and result, right? So now we can say input and result dot 0 and input and result dot 1, right? And those are the two values. That's it, right? Super simple, okay? We can do the same down here, except for regex builder. We'll fix that after we copy it. Regex builder, right? And now we can do arguments here like this, and then add this as well. Boom. Okay, cool. So now both of these functions are going to exercise each of these cases, one after, or not one after the other, but in parallel. The other thing to note is that Swift testing unit tests all run concurrently. Unless specified otherwise, they run at the same time. The way that you tell it not to run at the same time is using something called traits. So if you go serialized like this, then it will run them one after the other rather than at the same time. That shouldn't ever really come up. It should be fine for you for them to run concurrently, but if you ever need it. You can also apply the same trait up here, right, to the after the name. You can apply the same one up here, and then it will serialize all tests within this suite, including otherwise. Because otherwise they'll run simultaneously across your all suites will all run simultaneously within your entire test plan. So Okay, so we're going to hit play here. And look at that. We ran. And we actually ran into some problems, right? Which, you know, we actually kind of expected. If we'll recall, we weren't exactly sure how many threes we needed here, right? And the answer is this many threes. This is how many threes we needed, right? Oh, also it needed to be 33, not 32. I don't know why I put 32. Listen, guys, I'm good at math, I promise, okay? I'm really good, I'm great with math. You all want me doing your math homework, for sure. I'd love to be able to copy paste this, but I don't think I can from there, but I think I can from here. Cool. So again, and here we have a wonderful, easy way to check and see, oh, what is getting returned, right, by these functions? Like precisely what are we getting, right? And then, you know, we can look at this and we can say, oh, this is great, but like, I'd rather it rounded, right? And so then we can set the test to be the rounded result that we would rather have, right? Like something like, you know, like this, like just, you know, make it round much earlier. So you could set it like that, and then you can just have your test be failing while you work on fixing your functions to match what you've changed, right? Very cool. Okay, that's something called test-driven development. It's a thing. We'll talk about it in the next segment. Okay, cool. So we've now fixed this this input result, right? So now when we run our test suite, what do we get? Oh goodness, it's having a time, isn't it? Okay, well, I believe it all passed because it says so here. This sometimes bugs out, like I said, cutting edge technology, okay? So there we go. Just leave it and come back and you're all good. Cool, awesome. All right, last but not least are tags. So, and test plans. So basically, these tests that we have in this file, right? This class 2 tests file, which I don't know why it's calling this package.swift. This is not a package.swift file. It's, oh no, I lost it. Wait, where was our file? Just close all of these. And then, oh gosh, losing my mouse. Here we go. In our arithmetic tests file, that is, you know, that has this suite in it, right? If we made another file with another suite, you know, we'd have more. And as you can see here, you know, with these very simple lines of code here, right? Okay, why are you still highlighted red? Stop highlighting red. We succeeded. Do I need to clean? Do I need to do a clean? Is that what I need to do? Is that what we're doing here? Xcode right now? Really? In front of the students? Okay. Okay, fine. We're doing it. Why are you opening the package? There we go. Fine, we cleaned. Okay, sometimes you need to do Command-Shift-K. Just wipe out the derived data folder. Don't worry about it. Sometimes you need to do that if there's like cached stuff, right? So, cool. Okay. So here we have our tests, we have our suites. But for this very, very simple set of cases, right? These are the tests we've written. We already have 8 tests, 8 test cases, okay? Because, you know, we have 4 cases and we're running those 4 cases for 2 different types of tests, right? And you know, in here, each of these files is a different regex builder. So we would actually, if we were exercising kind of the whole thing and all of the different regexes with all of these cases, we would be looking at 5 times 4, 20 tests, right? These numbers kind of grow and grow and grow. Likewise, if you had a second parameter here that is another collection of things, then what it does is it checks item 0 against item 0, and item 0 with item 1, and item 0 with item 2, and then it goes to the next 1 on the first, and then 0, 1, 1, 1, 2, and so on and so forth. So you end up with n times m tests from a single function, where n is the length of the input array for the first parameter, and m is the length of the input array for the second parameter. This can explode to be very big, very fast. This is also why with Swift testing, you're only ever allowed to use 2 input parameters. They don't allow a third because at that point you're looking at exponential growth of how many tests you're running, and that kind of, that's just too much. So don't do that. You're losing value at that point. You need more specific tests. If you want 3 parameterized functions, you're doing something wrong with your architecture. So, okay, right. So managing these tests can be kind of a pain, right? Especially if you have tests that are somewhat related across different suites. So, for example, these are all valid inputs, right? We might have an invalid inputs, right, that we want to use, okay? And this one only has useless stuff, right? And it's actually not going to have results, right? Because it's going to fail, right? But this would be letters, right? Or an exclamation mark within the numbers, right? Or 2 periods, right? Like that, right? So these are invalid inputs. Okay, here we go. And you'd have a different function that you would use for those, right? It would be, because your input parameter is different, right? It would be func basic regex test invalid, right? And then you do invalid inputs, something like that. Oh, no, I guess you wouldn't. You would instead say string, input string, right? And then here at test, you'd have arguments, and that would be invalid inputs, right? And then, here you would, do this again, right? Now, the thing to note here, because this is an invalid input, right? We would expect this to, if it doesn't work, if the input doesn't work, what do we do, right? I would expect this function to throw, but again, when I wrote this example, we hadn't learned throws yet, I don't believe. So, oh no, we had. Here it is. It's right here. Okay, never mind then. I don't know. Oh, you know what? It doesn't throw. Yeah, I don't know. It should. I wrote it poorly. Don't be like me. Throw when you have an error. So again, this would be something where we would have, this be expect hashtag expect throws, right? And then we'd have our error dot invalid input or whatever, right? And then we do this function within, right? Obviously we can't do that, right? But that's okay. So why am I talking about this? Basically, you might say, have these, set up, okay, this is now, we'll say this struct is for the basic regexes, and then we'll have a different struct for the regex builders, and then a different struct for the different, kinds of things we test for short regex, and one for substrings. But at the same time, these are very similar to the ones in the other structs, right? So we want to be able to identify them. So there is a trait that you can add to tests called tags, okay? And with tags, you can basically pass in any number of custom tags that you want to exist on that test. You can also do this with suites. Now, you don't want to do this too much, but basically, you can use this to help you understand what kind of test you're dealing with, right? So you can call this unit, you can call this invalid, right? Or chaos testing is technically what it's called, and we can get into this more in the next segment because we talk about some of this stuff there. And it's, it's giving an issue because I don't remember exactly the syntax for this. Of course, which is, just lovely. This is tag. Right. Oh, okay. Yeah. So you don't use strings. You have to define these tags. You do extension on tag, and then you do static let, chaos test, right? Something, or tag, and then at tag, like that, right? Var. And so now in tags, you can say dot chaos test, right? Which is cool. And then you do need a comma here usually. And then this is just complaining because invalid input doesn't exist, right? So we can just comment this out. It'll compile. Now you can use these tags to basically filter your test runs. So you can say, oh, I only want to run tests with these tags right now. And you can create things called test plans, which basically, one gets auto-made for you by default, but you can go in and you can edit it, right? And you can say, oh, cool, here's my test plan, yeah, but I don't want this test to run. Yeah, save it, give it a name, put it in somewhere, and now it's a file that you can access, cool. But yeah, I don't want this one to run, or well, actually this invalid input one's broken, so we don't want it to run, right? And so now when you go here, and you hit, this up here, right? This one, doesn't run, right? Or I guess it does, because we clicked it from here. But if you do it from the test plan, shouldn't. You can also exclude tags. So you can say, let's just exclude our chaos tests, and now it's excluded, right? And so now when you do it, it won't run them. You can also kind of, show the different tags, right? And show the breakdown of things within tags. You'll note that I can't click these. I can't click to run because they're disabled, right? You can have multiple test plans that you've created with multiple rules for what tags to include or exclude. And then you can access them from this dropdown. So you can pick between your test plans. And then you can also use test plans with automation and build pipelines, but we don't need to get into that too much. Okay, cool. So I've gone a little over time here for this segment, but I just wanted to make sure we were pretty thorough with our test coverage stuff. Is there any questions about tests here before I quickly show you how to get them set up in a app project? Cool. Okay, so let's look at an app project real quick. If you are making a new app project, this is very, very simple to do, obviously, right? You go here, you click next, and then you pick your testing system, right? Swift testing with XCTest UI tests is the one you want. So if you've selected that before with your project that you've created, great, you're all set up. But let's say that you haven't, right? Let's say that you weren't prescient, you didn't know this was coming, and so you didn't do that, right? So now you have some, project, right, that doesn't have tests set up. Like this one, for example, this hiking trails project, right? I think we built this during one of the things, one of the classes. I think this was the Swift data class, right? There's no tests here, okay? So how do we add a test? We're not a Swift package, so we don't have a package.swift file to add a test target to, right? Instead, what we have is our Xcode project file, which you can access by clicking on this. We also have these targets down here. Ah, targets, that sounds familiar. And a fun little plus button all the way at the very bottom, just hiding there, right, lurking. So you click plus here, and you get a lot of different options, right? You can then type test, and you can pick UI testing bundle or unit testing bundle. For our purposes, we're discussing unit testing bundles. I will explain what UI tests are and why you probably don't want to use them in the next slide deck. So here, now you pick our target. Cool, it gave us a good name. It's all set up with Swift testing and everything. This is all everything we want. It's picking the target that it's depending on, that it's testing, the project that we're in, our language, everything. Great, cool, okay.
I missed this part. Which one we choose?
Unit tests. Yeah, so unit test suite. It was, where is it? So if you filter on test, unit testing bundle, sorry. Unit testing bundle. UI testing is different. We'll talk about that in the next slide deck. So unit testing bundle. Okay, so we click finish. Cool. It creates a folder over here for us, and it gives us our very first test file. That's it. That's how you get tests in a Xcode project. So now you have tests. You go here, you have this automatic test plan. If you ever open it up, it's like, hey, you should save this as a file. And you're like, yeah, okay, fine, I guess I'll do it, And then you do, and then it's here, and now you can see it as a file, right? Whatever, right? Cool. Awesome. Okay. Any further questions about tests, test suites, doing it in Xcode, anything like that? Awesome. All right, we are on break once again.